In this lecture, I'll let you know how to send ethers to smart contracts. So, why do we need to send ethers to smart contracts? Let's see. So, let's say this person out here is a buyer, and this is the smart contract, and this person is the seller. So the seller gives his property, like you can say a piece of land, and this person wants to buy that. So what this person does, he gives all the property documents inside the inside the smart contract, and this person puts his money inside the smart contract. Both of these stay until both are verified, and once both are verified, then there will be an exchange of the resources. So the land will be given to this person and the money will be returned to this person. And this is the best part of blockchain, that no need of middleware or any third party or intermediary person to do this. The smart contract will acquire both the resources, and then only it will check and then give it to either parties. So there's nothing like this person pays and this person doesn't give the property documents. So meanwhile, you have to give out the ethers to the smart contract. It can be in the case of bidding also. You are putting a land, and also people are putting up money, and all these money or the ethers, you can say, is stored in this smart contract. So we need to send some ethers or some cryptocurrencies to the smart contract to work with, or to keep it safely, so that this thing will be trusting. And then let's see what we can do is, we can send ethers to this smart contract via two functions. One is the execute function. So you execute some function which will have payable keyword, so that you can pay to the functions. I've already explained all these in my previous video or my previous course, you can say. And the receive is basically the fallback function of the 0.5.0 Solidity version. Now in the 0.6.0, it has been changed to the receive function. So what this receive function will do, if you just send a transaction directly to the smart contract, it will take the ethers to this receive function and then put it in the smart contract. So how is it going to keep this ethers? So every smart contract, as you know, will have an address. Let's say 0x47 is the address of this smart contract. So what happens? This address will keep all the ethers that is given to it. Let's say it has been given 3 ethers. It will keep it. And the owner of the function can write the contract as who can withdraw the money. So in this case, the money will be given to the person who has given his land. So his address will be taken, this person's address will be taken, put it into the smart contract, and the smart contract will pay this person all the ethers, or the ethers which has been given by this person. So that is a lot of theory. Let's go into the practical and let's check out how to leverage all these. So let's see where we have stopped at the last time. So we have our simple storage.sol out here. We have the app.js out here. And also we have our Ganache running. If your Ganache is not running, please switch it on via the application. Let's make some changes out here in the smart contract. So let's first change the Solidity compiler version, make it to 0.6.0. Now keep the contract name as the same, because we have deployed all the contract with the same name, like this.abi, simple storage contract and all. So let's keep the contract name as the same. Next up, we can change all the functionality and the variables inside it. So how to start this contract? Let's see. Okay, so what we can do is we can keep an identifier, so a string, and identifier like ident. So now we will have two functions, one to execute the function and then send the ethers, and one for direct ether send. So how can we write function, let's keep the name as send ether, then make it public, and then the most important thing is you have to make it payable. So payable is the keyword by which your function can take ethers via the transaction and save it to the address of the smart contract. So in this function, what we will do, we will just change the identifier to, let's say, send ether got called. Ether got called. Yeah, I guess that's it. And then for the next function, we'll have a fallback function, which is the receive function in the latest smart contract compiler, the receive. You have to make it external so that it can be called from outside due to the transaction is coming directly and not calling any function. That, and you have to also make it payable so that it can take ethers and store it in the address corresponding to this smart contract. And what we can do inside it, we can actually write ident, and then this is the fallback function, fallback got called. So that's it for this. So only two functions, one will take the ethers via executing a function and one will directly take the ethers by the fallback, and both will store the ethers at this smart contract's address on the deployed network. Now go to your console. Now press truffle migrate -reset to redeploy this contract on the network which is preferred. It will redeploy it on Ganache basically. So let's wait and check it out. It says compiling your contracts. I don't think there's any error. Okay, compilation failed. Did I miss a bracket somewhere? Oh, I forgot a semicolon, sorry. Let's redeploy it again. It seems so it's getting compiled. Okay, it got compiled. The initial migrations.js is getting replaced because we had the older contracts which were deployed on the same network. Let's see. Okay, everything worked fine. Now next we'll go to the app.js.